Some worlds defy destruction. Meet WASP-12b. There are places in the universe where nothing should survive. Worlds so extreme that even the idea of stability breaks down. WASP-12b is one of them. It is not a rocky planet like Earth, not a distant ice giant like Neptune. It is something else entirely. A hot Jupiter, a massive gas giant orbiting dangerously close to its star. So close that it completes an entire orbit in just a little over one Earth day. That means a year on WASP-12b lasts about 24 hours. And at that distance, the star dominates everything. The planet is locked in place, gravitationally bound, so that one side always faces the star, while the other is trapped in permanent darkness. No rotation, no escape. One side burns, the other never sees light. Because WASP-12b should be dead. Its atmosphere is being stripped away, stretched into space by the star's gravity. Its temperature is so high that molecules break apart. Its outer layers are literally evaporating. This is not a stable planet. It is a planet in the process of being destroyed. And yet, it is still active, its atmosphere moves, its heat redistributes, its dark side behaves in ways that shouldn't be possible. WASP-12b is one of the darkest planets ever discovered. It absorbs almost all incoming light, reflecting less than charcoal, less than fresh asphalt. It is a world that doesn't shine, a world that swallows light and still burns. Everything about it contradicts expectations. A planet that should have been torn apart long ago. A world that should be silent, frozen on one side, and chaotic on the other. But instead, it exists in a strange balance. Dying, but active. Destroyed, but still evolving. WASP-12b is not just extreme, it is a glimpse into what happens when a planet is pushed beyond its limits and refuses to collapse. WASP-12b does not have a normal day. It doesn't rotate the way Earth does. It doesn't spin freely under its star. It is locked, gravitationally trapped in what scientists call tidal locking. This means one side of the planet always faces its star, forever. The same hemisphere is blasted with constant radiation, while the opposite side is locked in permanent night. No sunrise, no cycle. Just endless day and endless darkness. On Earth, day and night balance temperature. Heat spreads. The planet stabilizes. But on WASP-12b, that balance is broken. The day side is exposed to relentless energy. Temperatures soar above 2,500 degrees Celsius, hot enough to melt and vaporize metals. Iron doesn't just heat up there, it turns into gas. Molecules are ripped apart. Atoms are pushed to their limits. It is not just hot, it is destructive. And the night side, it should be frozen, cut off from the star, it receives no direct radiation. In a simple system, that side should collapse into darkness and cold. But that's not what happens. Because the planet is so close to its star, gravity has stretched it. WASP-12b is not perfectly round. It is distorted, pulled into an elongated shape, like a droplet being stretched. The star's gravity is constantly tugging at it, heating it internally, stirring its atmosphere. Even the dark side is not truly isolated. Energy moves, heat flows. The boundary between day and night, called the terminator line, is not calm. It is a zone of extreme gradients, where temperatures drop rapidly and winds accelerate violently. This is not a simple two-sided world. It is a planet caught in a constant struggle between light and darkness. And even though half of it has never seen its star, it is far from dead. Most planets reflect light. That's how we see them. Even distant worlds shine faintly, bouncing back a portion of the starlight that hits them. Clouds, ice, and atmospheres scatter light in different ways, giving planets their color. Earth reflects about 30% of the sunlight it receives. Venus reflects even more, its thick clouds acting like a mirror. Jupiter and Saturn glow softly, their cloud tops catching light from afar. But WASP-12b is different. It doesn't reflect. It absorbs, almost completely. Measurements show that WASP-12b reflects less than 1% of incoming light. That makes it darker than charcoal, darker than fresh asphalt, one of the darkest known planets in the universe. At first, this doesn't make sense. Gas giants usually have thick cloud layers that scatter light. They appear bright or colorful. So why is WASP-12b so black? The answer lies in its temperature. At over 2,500 degrees Celsius, the atmosphere is too hot for reflective clouds to form. On cooler planets, clouds are made of water droplets, ammonia crystals, or methane ice. On WASP-12b, those compounds cannot exist in stable form. They break apart. Instead of clouds, the atmosphere becomes a chaotic mixture of atomic gases and ionized particles. Light enters this environment and doesn't come back. Photons are absorbed by atoms and molecules, scattered internally, and lost as heat. There is no reflective surface, no bright cloud layer, just a deep, absorbing atmosphere. But there may be something even more extreme happening. Some scientists believe that WASP-12b's atmosphere contains exotic compounds, possibly vaporized metals, like iron and magnesium. At those temperatures, even rock-forming elements can exist as gas. This creates an atmosphere that behaves more like a furnace than a sky, a place where light is not reflected, but consumed. And because the planet is tidally locked, the day side is constantly fed with incoming radiation. It doesn't cool. It doesn't reset. It absorbs and absorbs, endlessly. From a distance, WASP-12b would appear almost invisible, a dark silhouette against the brightness of its star, a planet that hides in plain sight. And yet, despite absorbing nearly all light, it radiates enormous amounts of heat. Because what it takes in, it must release. In infrared wavelengths, WASP-12b glows intensely, not with reflected light, but with its own thermal emission. It is a paradox, a planet that is both invisible and blazing. Dark yet burning. WASP-12b does not shine. It devours light, and in doing so, it becomes something else entirely. Not just a planet, but a world defined by absorption, heat, and extreme physics. At temperatures above 2,500 degrees Celsius, something strange is expected to happen. Everything should even out. Heat should spread, energy should redistribute. Differences between regions should fade. On a planet like WASP-12b, blasted constantly by its star, scientists expected a relatively uniform atmosphere. After all, gas giants don't have solid surfaces. Their atmospheres can move freely. Winds can carry heat from one side to another. In theory, the extreme heat of the day side should flow across the planet, warming the night side. The result should be balance. But that's not what we see. Observations suggest that WASP-12b has a significant temperature difference between its day side and night side. The day side is scorching. The night side, while still incredibly hot by Earth standards, is much cooler. That means heat is not distributing evenly, and that breaks expectations. Because at those temperatures, atmospheric circulation should be incredibly efficient. Gas should move rapidly. Energy should spread. So why doesn't it? One possibility is that the atmosphere is being constantly disrupted. Remember, WASP-12b is losing mass, its outer layers are being stretched and pulled away by its star's gravity. This process creates turbulence, instability. Instead of a smooth flow of heat, the atmosphere may be chaotic, with regions of intense mixing and others where energy is lost to space. Another factor is radiative cooling. The planet absorbs enormous amounts of energy, but it also emits heat quickly in infrared wavelengths. If the day side radiates energy faster than it can transport it, the temperature difference remains. It becomes a competition. Transport versus radiation. And on WASP 12b, radiation may be winning. There's also the possibility of atmospheric composition playing a role. Different gases absorb and emit energy differently. If certain layers trap heat while others release it, the vertical structure of the atmosphere becomes complex. Heat doesn't just move sideways, it moves up and down. And that creates gradients. Instead of a uniform world, WASP 12b becomes layered, dynamic, unpredictable. The expectation was simple. Extreme heat should create uniformity. But reality is more complicated. Even under constant stellar bombardment, the planet resists balance. Its atmosphere refuses to settle. WASP 12b is not stable. It is constantly being pushed, pulled, heated, and stripped. And in that chaos, even something as basic as temperature becomes uneven. A world that should be uniform is not. If one side of WASP 12b is burning, the other side should be frozen. That's the expectation. No sunlight, no direct energy input. Just endless darkness. On a simple, tidally locked world, the night side should collapse into cold. Temperatures should drop dramatically. The atmosphere should condense, slow down, and stabilize. But WASP 12b refuses to follow that logic. Its dark side is not cold, not even close. Instead, it remains incredibly hot, hundreds, even thousands of degrees. Not as hot as the day side, but far from frozen. Which means one thing. Heat is moving, and it's moving fast. The only way to keep the night side that warm is through powerful atmospheric circulation. Winds must be transporting energy from the day side across the planet. But not just winds, extreme winds, supersonic flows. Models suggest that winds on WASP 12b can reach several kilometers per second, far faster than anything we see on Earth. These winds carry heat across the Terminator line, the boundary between day and night, redistributing energy into the dark hemisphere. But here's the problem. Even with those winds, the night side should still be cooler than what we observe, which means something else is happening. One possibility is that the atmosphere is so thick and dynamic that it traps heat efficiently, even without direct starlight. Another is that internal processes, tidal heating caused by the star's gravity, are adding energy from within. As the planet is stretched and distorted, friction inside its layers may generate additional heat. So the night side is not just receiving energy, it may be producing some of its own. There's also the question of chemical reactions. At these extreme temperatures, molecules are constantly breaking apart and recombining. These reactions can release or absorb energy, affecting the thermal balance. The dark side becomes a laboratory of high-energy chemistry. And then there's radiation. Even without sunlight, the night side still emits infrared radiation, losing energy to space. So again, it becomes a balance. Incoming heat versus outgoing radiation. Transport versus loss. And somehow, the system stabilizes at a temperature far higher than expected. The result is a paradox. A world locked in eternal darkness that refuses to become cold. A night side that should be dead, but remains active. WASP 12b is not divided into hot and cold. It is a continuous system driven by forces that don't stop at the edge of light. Even in darkness, it lives. WASP 12b is not just extreme. It is dying, slowly, constantly, inevitably. The planet orbits so close to its star that gravity is no longer just holding it in place. It is pulling it apart. The star's tidal forces stretch the planet, distorting it into an elongated shape. Its atmosphere is no longer tightly bound. Instead, It is leaking into space. Observations show that WASP-12b is surrounded by a cloud of escaping gas, hydrogen, helium, and heavier elements being stripped away. This is called atmospheric escape. But on WASP-12b, it's happening at an extreme level. The outer layers of the planet are heated so intensely that they expand outward, reaching a point where gravity can no longer hold them. From there, stellar radiation and tidal forces do the rest. The atmosphere flows away from the planet, like smoke being pulled into a vacuum. Some of that material forms a glowing envelope around the planet. Some of it trails behind, like a comet's tail. WASP-12b is literally leaving a stream of itself behind as it orbits its star. And over time, that loss adds up. The planet is losing mass bit by bit, layer by layer. It may not happen quickly on human timescales, but astronomically it is significant. Eventually, WASP-12b could lose a large portion of its atmosphere. What remains might be a smaller, denser core, a stripped remnant of what was once a gas giant. In other words, we may be witnessing a transformation. A planet being reshaped by its star. Not through collision, not through formation, but through destruction. WASP-12b is not stable, it is being consumed. And yet, even as it loses itself, it remains active. If WASP-12b were truly dying quietly, its atmosphere would collapse. It would thin out. Cool down, become still. But the opposite is happening. Its atmosphere is in motion, violent motion. Because to connect a burning day side and a dark night side, the planet needs one thing: wind. Not gentle currents, not steady breezes, but extreme planet-wide flows. On WASP-12b, winds are believed to reach several kilometers per second. That's faster than the speed of sound in many conditions. These are supersonic winds, racing across the planet, carrying heat from one hemisphere to the other. They are driven by the enormous temperature difference between day and night. Hot gas rises on the day side, expands, and is pushed toward the night side. As it moves, it accelerates. By the time it crosses the terminator, the boundary between light and darkness, it is moving at incredible speeds. But this flow is not smooth. It is turbulent, chaotic. Layers of atmosphere move at different speeds. Shock waves may form where flows collide. Energy is constantly being redistributed. And because the planet is tidally locked, this pattern never resets. There is no pause, no rotation to redistribute heating evenly over time. The system runs continuously. Day feeds heat, winds transport it. Night radiates it away. A constant cycle. But even this is complicated by the fact that the planet is losing its atmosphere. As gas escapes into space, it alters pressure gradients. It changes how winds behave. The atmosphere is not just moving, it is thinning, stretching, breaking apart. And yet, despite all of this, it remains active. WASP-12b is not a quiet, fading world. It is dynamic, driven by forces so extreme that even as it is being destroyed, it refuses to become still. WASP-12b doesn't just challenge what we know about planets, it expands it. Before discovering worlds like this, planetary science was based mostly on our own solar system. Rocky planets, close to the sun, gas giants farther out, clear categories, predictable behavior. But WASP-12b doesn't fit those categories. It is a gas giant in a place where gas giants shouldn't exist. It is tidally locked, but still violently dynamic. It is losing its atmosphere, but still sustaining complex circulation. It is dark, yet radiates enormous energy. This forces scientists to rethink the rules. Atmospheres don't behave the same way under extreme radiation. Heat doesn't distribute the same way at thousands of degrees. Gravity doesn't just hold planets together. It can tear them apart. Even chemistry changes. At these temperatures, familiar molecules break down. new forms of matter emerge. Exotic reactions dominate. WASP 12b is not just a planet. It is a natural laboratory, a place where physics operates at the edge of what we understand. And as we discover more exoplanets like it, we begin to see a pattern. The universe is not limited to the conditions we see around us. There are worlds far more extreme, more chaotic, more unstable. And yet, they exist. WASP 12b is not unique. It is just one example of a class of worlds we are only beginning to understand. Hot Jupiters, ultra-close orbits, tidally locked planets. These systems are common across the galaxy, and that changes everything. For a long time, we assumed planetary systems would resemble our own. Rocky worlds close in, gas giants farther out. But exoplanet discoveries have shattered that assumption. Planets can migrate. Orbits can shift. Worlds can form in places we never expected. And when they do, the results can be extreme. WASP 12b shows us that planets can survive conditions that seem impossible, that they can remain active even while being destroyed. That darkness does not mean inactivity, and proximity does not guarantee stability. When we look at distant stars and detect planets, we are not just seeing variations of Earth. We are seeing a spectrum, a vast range of possibilities, and many of them are far stranger than anything in our solar system. Yes, sir, WASP 12b should be silent, locked in darkness, stripped by its star. A world fading into nothing. But it isn't. It moves. It burns. It survives. Even in eternal night, its atmosphere flows. Its heat persists. Its structure endures. This planet proves something unexpected. Darkness does not mean death. Even at the edge of destruction, a world can remain active, violent, dynamic, alive in motion. WASP 12b is not just a dying planet. It is a reminder that the universe does not follow our expectations.